Howdy, 7th grade. Today we're going to talk about this thing called geometric probability. But first I want to do a little bit of review, and we are going to review a little bit of theoretical probability, which we've done in the past. So theoretical probability is like when we're pulling marbles out of the bag or when we're rolling dice. When we do that, the probability is equal to the part divided by the whole. So it's a fraction. So the whole normally represents, everything that could happen, and the part is the proportion or the, part of things that we're asking what's the probability of this happening. So for geometric probability, our problems here are going to look like darts. There'll be a lot that say we are throwing darts. There's going to be things for construction. There's going to be things about dropping balls onto a sheet of paper, which I think is kind of ridiculous. But anyways, basically it's going to look like we're aiming. Aiming is spelled like that. There we go. Aiming for a target. And we're going to be asking what's the probability of hitting this part of the target. So if we follow our formula we already knew, that the probability of something is going to equal the part that we want divided by the whole thing, then a geometric probability becomes a little bit more easy, because if I have a target, so let's do an example. I have a target and I'm going to shoot a dart at it because, I don't know, darts are fun, I suppose. Let's say this inner circle has a radius of 1, the outer circle has a radius of 3. And I'm wondering, what is the probability of getting a bullseye? And I'm going to make it a little bit more mathematical here. I'm going to say assuming I hit the target. That's just going to make sure that our hole that I'm talking about is the target. Otherwise, it's possible I would hit a dart way over here, and then that would kind of mess up all of my probability stuff. So we're just going to assume I hit the target, even though when I play darts, I rarely hit the target. So my probability is going to equal the part over the whole. So I have to think, when I'm aiming darts at a target, what am I aiming it at? And the answer would be the area. So the area is where the dart can land, so I want to compare the areas. So for targets, we'll use area. And the part that I want is going to be the bullseye right in here. And the whole is going to be the entire target, which would be all of this. And if you'll notice, that does include the bullseye. So this is the full target. And we are going to use the area still. So I know that the area of my bullseye is going to be the area of bullseye. It's going to be equal to pi times the radius squared. My radius here, if we look again, right here is 1. So that would be equal to pi times 1 squared, and that's just equal to pi. So I know that now. Then the question is, what's the area of my whole target? And it's going to be very similar. So my area of target, if we look up here, I can see that the entire target has a radius of 3. So that'd be pi times 3 squared, which is 9 pi. So I know that my probability, looking back at my formula up here, is going to be the part divided by the whole. So my area, the bullseye, is my part, and that's just pi divided by, and the whole is the target, which is 9 pi on the bottom. I know that up top when it says pi, it really means I have 1 pi. So I'm going to write that down to make it a little bit easier. And then I can cancel that out to get 1 over 9. So I canceled out my pi's. They went away. And my final answer would be I have a probability of 1 over 9. Sometimes we'll get a few stranger questions. I'll show you guys one that we can actually use to calculate pi. So if you want to figure out what pi is, this is a way of doing it. But if I have a sheet of paper that is a square with a circle inside of it, we're going to pretend that the circle looks nice and is properly inside the square. I want to know that what is the probability of hitting the circle, assuming I land on the square. And just to get some units in here, I'm going to put that there's a radius of 1, and we should be good to go. So, my probability is still going to be the part over the whole, and my part is going to be the area of the circle, and my whole is going to be the area of the square. So what I want to do now is I'm going to find the area of my circle. It's got a radius of 1. So because I know it has a radius of 1, its area is going to be pi times r squared, which is going to be equal to pi times 1 squared, or just pi. So that's the area of my circle is pi here. The area of my square is going to be a little bit harder to find, but I know that halfway down this side is 1, which means that the entire side, I'll pick a different color for that. Here we go. The entire side here is 2. So if the whole side is 2, I know that the area of the square is base times height, which in this case is going to be 2 times 2, which is 4. So then I can say that my probability is the area of the circle divided by the area of the square, and we just found out that that would be pi divided by 4, and that would be the probability of throwing a dart, hitting the square, and what the probability is of hitting the circle if I did hit the square is pi over 4. So that's what these problems are going to look like. A lot of finding area and then dividing them. So again, what you want to be able to do is to figure out what is the part of the probability you're finding, what is the whole, and do a quick division. Just like that, you'll be done. I'll see you all tomorrow.